So today what we are going to do is I'm going to use I'm going to write this code for my MCP 47, my MCP 4725. So I'm going to write that code. So what I'm going to do is now the best I have to do, or what I have to do is, let me open ChatGPT. But before that, I have to know the addresses. So let me select my board. So now I've connected it to an ESP32. Let me see if I'll find what is on this board, if I'll find anything. So I'm going to use ChatGPT to write my code to test the MPC, because if you watch the code, I have to be able to change the addresses. So one should be 0x6 0x60, and the other should be 0x61. But what I'm going to do now is I have a project or a test file for testing the the SDA and SCK. So let me see for I to C device. Let me load that sketches app. Then I'll use it to test and see if I'm going to find anything related to my the MCP that I'm using. So what the MCP does is, the MCP acts as a potentiometer, but it's a digital potentiometer. So when we say it's a digital potentiometer, that means that's what is going to control the voltage on my power supply. So instead of me using a potentiometer, let me see if I can show you a potentiometer. So you can see this blue thing, that's the potentiometer that you turn, then the resistor in it will start changing your voltages. So now instead of me using that, or I can use any potentiometer that I know, which is around 5k ohms, I'm going to use my MCPs. But before I do that, I have to test them first. So what I'm going to do is let ChatGPT write me a code. So before I do that, I'm using I to C. So I have to test my device, then I know how to connect it. So if you can see, so these are the connection, but these are not the main connection. There are other connections that I have to deal with also, which will be the out voltage. So whenever the potentiometer or the MPC sends a voltage, it has to short it to ground. So I'll be doing that, and I've already done, if you can see, for this is what I'm going to use for now, my buck converter that I'm going to use for now. So Okay, so before I copy this code, as it is written, it defines it because it's using I2C. That's why it has written wire.h. So it sets the address for it. Then serial print. So in my serial print, that's where I'm going to see the changes. So this same code can be used for Arduino. Just that with Arduino, I'll just find where I can see my SDA and SCL, or some other displays to do it SCK. So and there is the delay. So there is the setup. Then check if connected. Okay, so it will tell me when it is connected. Then write MPC unit 16T-T value. Okay, so you can see the AI has neatly commented on all the codes. So fast mode rating, and it has really done a good job for me. And it says what this code does is initialize the RTC. So let me do my code first. So this is my code that I'm going to run, and I need to open a new sketch also because I'm going to use my this is a new sketch. So let me open my I2C tester. So with this I2C tester, let me also upload it, so I can upload it to any controller. So let me compile and upload my I2C. I'll not be using this, so I'll go to ChatGPT so that I can use ChatGPT. I can save it and write it extra. Want extra also I can save output to EEPROM mode. Use the fruit library that you waveform generator. Okay, let me do yes. But before I do yes, let me copy the code. So I've copied this code, and let me enter my yes so that it advances the code for me. Let me close it, and let me paste my code here. So now that I've pasted my code here, when it detects the RTC, it will let me know. So I have two MPCs, but I'm trying to compile this. Compiling will take much time, so I'll try to compile it. We'll wait for it to finish the compiling. Then I'm going to test on my ground. I'll test on one first. That means I have to test on my ground and my signal. So normally with these devices, what it does is with these devices, what it does, or how it's going to help my smart power supply is going to make my smart power supply look more of let's say I'll be able to control everything. So I'm not going to turn any buttons. So the only thing I'll be turning will be the controller, which is to set voltage, to set current. And because I'm using both voltage and current to do the work, so because I'm using them to do the work, so that my project will be a bit smarter. So when I want to set a voltage, I just turn the button to set that voltage. And if you watch my previous videos, you get to know that. So I don't know why my compilation is that weak. So I'll wait for the compilation to be done. I'll wait for the compilation to be done, then I'll know what to do. So as we are waiting, let me check on ChatGPT second code also. So okay, sine wave, and I have a screen here, so I can just tell ChatGPT to do the screen for me so that I can use it to run my test. So I have a screen on my how to see devices that I'm testing. So I can speak to ChatGPT to do that for me. So I can speak to ChatGPT to do that for me. So before I do that, I need to check one or two things first before I do that. So you can see it's saying touch or OLED, but the only thing I need to do is to just test it, that if it is working. And ChatGPT has written, oh no, okay. So let me see. Great. Let me type all. So I think ChatGPT is now going to write the code for me. So it has given me. So with the Bluetooth serial, if I upgrade my ESP32, I will not be able to use it. So I'll not do that upgrade. So since I'm still using the 2.0, I've not upgraded my how to see it. So I'm still waiting. Why is this compiling keeping that long? It's not even started anything yet. Wow. So with this code I'm trying to upload onto this microcontroller, what it does is it only shows me the addresses. So I'm going to see if my two I2C MCP are having the same address or they are having two different addresses. Then I'll know how to go about it. Then I'll test them. So one has to be ground and one has to be the output. But with my power supply, with my buck converter, I don't know it for now. So what I'm building is a power supply that has a UPS, or let me say a power supply Yeah, that has a UPS. So anytime I'm doing programming and the light goes off, my power supply will still be working, which is not going to leave me as which is not going to damage the ECU that I'm trying to program, because normally it happens a lot when you live at a place that the power is not stable. You can't predict when the light will go off, so when you are doing programming it puts you at a risk, because the moment there is any mistake or any error, you end up losing the control board, or you end up breaking the control board, let me put it that way. You end up breaking the control board. So with this one, I'm still waiting for the compiler to finish compiling the code and upload it. Then I can know how to see addresses that I have. Then I'll upload this code for testing the MCP4725. Then also I'll upload this code also. I'm just reading through this code to see. Let me tell ChatGPT that I'll be using add OLED 0.6. Let me see where this code has gotten to. So it's almost done. Let me see ChatGPT code that it has also compiled for me. So it's telling me something. Okay. What is the compilation project going to do? Scan I2C buses manual. So the DAC is digital analog conversion. So it will convert digital signal into analog signal. Yeah, the type is using JAM. So this is the waveform generator. So simply I can also generate waveform generator, and I have my scope here. After everything, I'll turn the scope on and test if my waveform generator will be working when I upload this one also. So that's what I should have done. Okay. So these are the codes that ChatGPT so has added. Okay, all these functions. Yes, and all. Also add retry code. Right, with this code, I'm hoping this finish. I don't know why today my compiling has taken that much time. I really don't know why. Just to test the addresses. So I'm hoping it should be able to finish it successfully. Okay, so he's telling me he's going to do these things, add Bluetooth function or waveform generator. So it looks like if I don't take care, this thing will divert me from my cost. And if you check, I'll be connecting this to my code is almost done. Okay, so it's now uploading the code. So I'll be connecting these two. One of them, one goes to out and one goes to ground. I think it should be able to share common ground. So one will go to out and one will go to ground. Everything out and ground, and one should go to ground. Okay, so there's an error uploading status. Why do I have this trouble? Let me check tools. Let me check this. ESP32. Why status 2? Okay, but let me do this. Let me go to serial. Let me open my serial monitor and see. Really don't know why today. I don't know. Okay, so from this code, let me see the serial monitor address that I'm using. I'm using 9600. So let me select the bandwidth to be 9600. 9600. Then let me restart my that means the code has not been uploaded successfully. Let me try uploading it again and see what I'm going to get. I don't know why the compiling took that long. So what I'm going to do is now I have to recompile the code again and see the results that I'll get. If not, then I have to compile this one rather and upload it. But this one too is something simple, so I think if this doesn't work, I'll be using this. Because I don't understand the error that came on it. So let me see. So it looks like ChatGPT is building what you call, I don't know why today my compiler is too slow. Let me try this and see if I'll be able to figure out why it's too slow compiling it. So let me go compile and upload. So the mistake that I saw was I've also connected my Arduino board to it. So now I've disconnected it. Let me see. I'm still having this. Let me minimize this. Let me see. Okay. So let me use this. Let me wait for it to finish compiling. Then I'll test the signal that will be coming out from that sensor. So whilst you are waiting for the compile to be done, I am now to calibrate my probe. Let me calibrate this probe that I have. Then after it is done, maybe I'll test, because we have to continue our project. Let me just fix it. Yeah. Oh. Okay, so now what I'm going to do is my voltage is too low. So normally you have to calibrate these testers, these probes. So I'm going to calibrate this probe. Yeah, I'm going to calibrate it. So let me. Today I don't know why everything is slow. So let me test my probe. Let me calibrate it. It has been a long while since I used this. It has been a long while since I used this thing. That's why I want to calibrate it and see if it's still working perfect. Whilst the code is trying to compile, let me do the calibration. So with this multimeter that I'm using, it can, so this is my multimeter that I use. It can also generate signal waveform. So I've placed it on the signal waveform so that I'll be able to do my calibration successfully. So let me connect ground to ground. Then let me connect this to, yeah. So instead of doing auto on the waveform, let me do my own settings. Let me go to, yeah, let me change to 1 volt per division. Then let me change my time. Let me check my signal properly. Okay, it looks like I'm having issue with my probe. So let me try and figure it out. Whilst we are waiting for the compilation, let me try and see if I can calibrate the probe that I'm using. Okay. Why is it behaving this way? So if I place in this thing, let me change my time base. Okay. So I'm doing my calibration. Whew. So I think this probe is having an issue. It's because of the heat that has been in heat for too much, a long time. Yeah, I think now I'm almost done with it. Yeah. Okay. So okay. So now I can adjust me. Okay. I have other probes also there that I can use to test for my signal. But for now, let me see if I can find this machine to see if I can test the signal itself. Yeah. Okay, so let me use this. So I'm using another device to test for it, which is a scope that has the signal generator. Let me turn on the scope. So this tells me that there is a problem with my probe. Wow. So either this probe is faulty or it's faulty. It's either this probe is faulty. I have another one also. Let me bring it out to test. It has been a long while since this one. I don't even think I've used it since I got the 2. And this is for O. I'm gonna fix that one also. And make the so this tells me that my probe is having an issue. Okay, let me start for my multimeter before I go to my scope. My multimeter, this, and let me see the, yeah, you can see I'm getting it. So with this one, what I'll do is I have to change the voltages. So let me switch it to, and let me change the voltages. Let me do 100. So with this one, this is where I can do my tuning. If you can see my waveform properly, you can see that my waveform is a bit messed up. So this is where I can do my tuning somehow say properly. So let me just, okay, let me see where it is on 100. Okay, so now let me have increase the time base. Let me increase my voltage so that I get it. Okay, 1 amp will be okay, 1 volt to be okay. And to see that if my